Chapter 11. Chapter 11 is talking about the volumes and the surface area of the three-dimensional shapes. And we said on Thursday that the two-dimensional shapes that they could be polygon or non-polygon shapes. Why we call them two-dimensional? These two-dimensional are length and width. But for the three-dimensional shapes, I'm not talking about, or we will not talk about parameter. We will not talk about area, parameter and area only for the two-dimensional shapes. For the three-dimensional shapes, we will talk about surface area and volume. So volume, surface area is related to three-dimensional shapes and area or parameter to two-dimensional shapes. The three-dimensionals the three-dimensionals are length, width, and height. That's why we call them three-dimensional shapes. Now, today we will start talking about the surface area of prism and cylinder. In this lesson, we will learn how can we find the surface area of the prism and cylinder. Now look at these shapes here. These shapes down here, all of them are prism, and this one is cylinder. What is the prism? The prism.
Are we going to take geometric probability chapter 10F?
Sorry?
Chapter 10F, did we take it?
Chapter what?
Chapter 10 lesson F.
Yes, we will talk about it in the probability.
Okay.
Now these are the prisms. The prisms are like this shape here. Now look at this shape here now. This one here, it is a cube. It has three shapes. Okay, look at here now. I will try to move it. Now, this one here, look at this shape. This shape now, it has two parallel faces. This one and this one. I'm talking about. This one. And also no. Now, so here now, let's talk about this surface and the down one here. Now, this face in orange one, and it's parallel here, okay? I hope that you can imagine, because if you are in the class, I was bring with me rectangular prism and show to her. Now, this is the face, and look at the other one here. There's a parallel face. These are two parallel faces. We call them bases. So this face and the other face that are parallel to each other, we call them faces. The other faces, the other sides, or the other faces, sorry, that are comes between these two faces, okay, we call them lateral faces. So the bases that are parallel with each other, we call them bases, and the other faces we call them lateral faces. So this is my first face. Here now, this is my first face. And there's a second one, which is down here. These two faces, which are parallel to each other, we call them bases. And the other faces, this one, and this one, and the one that is here, and the one that's in the other side, all of these now we call them lateral faces. This is now for the prism. Now, as you say here, this shape now, look at this shape here. Look at its base. The base here is rectangle or circle. Now, so the prism, it is a polygons faces. The two polygons faces are parallel to each other. And there's another faces that connects between these two faces. We call them lateral. So the bases, it could be triangle. So this base here, it could be triangle. It could be circle. It could be rectangle. It could be pentagon, hexagon. All the polygon shapes that we talked about them, or trapezoid, kite, rhombuses, all the polygon shapes that we talked about them in the chapter 10. So the base here, as you say, it could be triangle, square, rectangle, pentagon, hexagon, and so on. But now, if the shape is not polygon, if the shape now is circle, like this one here, if it is circle, we will call them now a cylinder. So look at the cylinder and the prism, they are the same. They have two parallel faces, and these two parallel faces have lateral faces that come between, or that connect between these two faces. If these two faces are polygon shape, we call them a prism. And if these two faces have a circle shape, we call them cylinder. This is the difference between the prism and the cylinder. They have two parallel faces. Both of them has two parallel faces. Next lesson, we will talk about pyramid and cone. For the cone and for the pyramid, they have the same shape, but the pyramid has only one base, not two bases. It has only one base, and the cone also, it has one base. But the pyramid, its base is polygon, and the cone, its base is non-polygon shape or circle shape. The prism and the cones, it has two parallel faces. Is it clear? What's the difference between the cylinder and the prism?
Yeah.
Okay. So now look at these shapes here, as I told you. Here now, this shape has a rectangle. Sorry. This one is, what happened? Did you see the slides?
No, we're still in the one before it.
Yeah.
Okay. Now,
Yeah. Yes.
now,
Yes, teacher.
as you see now, as we talked before, these are the prism and this is a cylinder. If the prism now, it has a rectangular base, we call them rectangular prism. Look at these two bases here, they are rectangle. Look at this base here, it's a square. Look at this base here, it is hexagon. So we say it's a hexagonal prism. Look at this base here, they are two triangles. And these two triangles are parallel to each other. This is a triangular prism. This one also, it will be a triangular prism. Look at this one here. We have a trapezoidal prism. So we will name the prism according to its base. If it is face is rectangle, we will say it's rectangular prism. If the base is hexagon, we will say hexagonal prism, triangular prism, and so on. If the shape now, it has a non-polygon shapes, it has a circle, we will call them cylinder. Now, so a prism, now today we will talk about the prism only. The prism is a polyhedron with two congruent parallel faces. We call it bases. As we said, this is, they are parallel to each other. So we call them bases. The other faces, we call them lateral faces. And you can name a prism using the shape of its bases. As we say, rectangular prism. That means the two faces are rectangles. This one here, it has a pentagon shape. So we will say it's a pentagonal prism. This one here, it's the base here is rectangle. We call them triangular prism. Now, one asked me, teacher, how can we know the faces? It must be parallel to each other. Look at this side here, this face, and the other one that is here. Are they parallel to each other?
No, they're not.
No.
You have these two. These two are parallel to each other. Now, imagine now that's you connect between these two. Now this is a triangular prism. Now look at this side, or this face here, and the other one here. These now are lateral faces. They are not parallel to each other. So we cannot name them a basis. They are lateral faces. But this face and the other one here, these now, we call them bases because they are
But
parallel.
teacher, they are parallel, right?
Yes, these two are parallel to each other. So we call them the bases. It must be parallel. Look at these two shapes. They are not two parallel to each other. So we cannot call them the bases. Now, and altitude. At the altitude, like we said in the shapes before, that it is a segment that is parallel to the side. This is the altitude in the two-dimensional shapes. We said that if they have this shape and we have this point here, from the center, there's a line segment that is perpendicular on the base. We call them an altitude. This is for the two-dimensional shapes. In the altitude here, in the three-dimensional shapes, it is also a perpendicular segment that joins the planes of the bases. What does it mean? Let's come back now here. Now, so we said that this is a face, and this is a face. There's another face here. And we talked about the lateral faces. Now, the altitude is a line segment that connects between the two parallel bases. And if you imagine, it will be perpendicular also on the bases. So the altitude, it's a line segment that is perpendicular in the two bases and connect between them. This will be now the altitude. Could be here, here, here. So now we can name them also as the height, which is the length of the altitude. So the altitude, it is a segment that connects between these two bases. It must be perpendicular on the bases. This altitude, or the height of this altitude, the length of this altitude, we call them a height. This is the definition of the altitude. Now, let's look now how can we find the surface area of the prism. But before talking about the surface area, we have two new definitions: the lateral area and the surface area. The lateral area is the sum of the areas of the lateral faces. We talked about the lateral faces. We say that these are the lateral faces. Now, the summation of these lateral faces, we call them the summation of the areas of the lateral faces, we call them lateral area. LA, it's mean the area of the lateral faces, the summation of the area of the lateral faces. And SA is the summation of the lateral area and the area of the two bases. If you want to find the area of all of this shape, all of these faces, sorry. Now, if you want to find the area of all of the faces, we call them surface area. If you want to find the area of this one here. So if you want to find now the area of all of the shapes, we will need to find the area of this side and this side and this side and number 4 here, the down one. Okay. I hope you get can imagine. And this one, you need to find the surface area of all of the 6 faces. If the 2 faces which are parallel, or we call them bases, so we need to find the area of the 2 bases, and then you need to find the area of the faces, or we call them lateral faces. So the surface area here is the summation of the lateral area and the 2 bases. This is a way how can we find the surface area of the prism. So if you want to find the surface area SA, it is the lateral area, the areas of all of the lateral faces, plus the area of the 2 bases. The area of the 2 bases, here, the first step, I will look at the base. What is the base? If it's a square, I will find the area of the square as we discussed before, then multiply it by 2. If it is pentagon, we will find the area of the pentagon as we learned, half AB, then multiply it by 2, then I will get the areas of the bases. Now, how can we find now the lateral area? The lateral area, to find it, you need to multiply the perimeter of the base. We need to find the perimeter of the base times the height of the base. This is the lateral area. And this parameter also, it depends on the shape. So the height, it can be found, but the perimeter and the base depend on the shape. If I'm talking about square, I have to remind how can we find the perimeter and the base of the square. If I'm talking about pentagon, we must remember how can we find the perimeter in times S, and how can we find the area, which is half the apothem times the perimeter. So we must learn or memorize all the formulas of the 2-dimensional shapes. This is now how can we find the surface area of the shape. Let's have an example now. What is the surface area of the prism at the right? Now look at the shape here.
Teacher, it's still in the old slide.
Now.
Yeah, it's showing.
Yeah, you didn't see what I said here. You didn't see these slides?
No.
Oh.
No, teacher, you were explaining and the one before.
So did you understand what I say, or shall I repeat?
I understood it, but I don't know about the others.
Yeah, me too. I understood it.
Me too.
The others?
Me too.
I'll repeat quickly.
Understood it.
The surface area. So if you want to find the surface, area, I need the lateral area plus 2 bases. This is how can we find the surface area. It is the lateral area plus the 2 bases. The 2 bases, I mean That's I need to find, oh, to look at the base. If the base is a square, I need to find the area of the square. So to find the area of the base, it depends on the shape. If the base is a square, I need to find the area of the square. The lateral area, I need also to find it. The lateral area is the perimeter times the height, where the perimeter here is it also depends on the shape. We need to find the perimeter of the base times the height, or the altitude. It is the length of the altitude that we talked about it then before. So to find the surface area, we need to find the lateral area plus 2 times the area of the bases, because the surface area is a summation of the areas of the lateral faces plus the areas of the two bases. Let's now have an example here. In this problem here now, as you see, we have two triangles. These two triangles are the faces, and there's a lateral faces that connect between these two triangles. Let's try now to find the surface area. So the surface area now is the lateral area plus 2 times the bases. So we need to find the surface area. First, you need to find the area of the base. Then you need to find the lateral area. Then add them, you will find the surface area. So the first thing that we need them is the area of the base. What is the base here? It is a triangle. So as we know, what is the area of the triangle?
Half the base multiplied by the height.
BH or half AB.
Half BH. This is for the area of the triangle. Look at this triangle now here down. It's like this. It's 3 and 4. So what is the base?
It's 6.
The base here.
Oh no, I was talking about the area. It's
By
3.
the way, here, this B small is the base. Here, B capital, it's mean the area of the base. So B here is the base. What is the base here? It's a 3. And what is the height that's perpendicular on the base? It is 4.
4.
So the whole area is 6 centimeters squared. So the B capital here, it is 6. Now let's talk about how can we find the lateral area. To find the lateral area, as we said, we need to find the perimeter times the height. So we need the height and the perimeter. What is the height? Look here, this is the height. That's connect between the two bases, which is 6. Now, where's the perimeter? The perimeter, as we know before, is the summation of all of the sides, or we can say it is n times s. This is the perimeter. How many sides we have for the triangle?
3.
This is not regular shape.
How is the height? Is 4.
Sorry?
The height is 4.
No.
Oh, this one. Okay.
This height is for the triangle, but this height is the altitude that connect between these two bases, which is 6. Now, so let's now feed the perimeter. The perimeter is the summation of all the sides, n times s if it is regular. So here we have a 3, 4, and here we will have 5 by finding it by Pythagorean theorem. 3 squared plus 4 squared, it will be 5 squared. So the area of the length of the hypotenuse, it will be 5. After that, the perimeter of this triangle, it will be 3 plus 4 plus 5. 7 plus 5 is 12. This is now the perimeter of this triangle, which is 12. So I found the perimeter. I multiply it by the height. 12 times 6, which is 72. This will be now the lateral area. And then we found the area of the base. Then after that, come back to find the surface area. The surface area is the lateral area, which is 72, plus 2 times the area of the base, which is 6. 12 plus 72 is 84, or 84 or 90, 94, I think, sorry. It is 94.
It's 84.
12 plus 72. Okay. 84 centimeter squared. This is for the surface area of this triangular prism. Is it clear?
Yes.
Yes.
So to find the surface area of the shape, we need to find the base, multiply the area of the base, multiply it by 2. Then we need to find the lateral area. Then after we adding them, we will find the surface area.